Hey, what's going on, guys? Let's do this problem right here. So here the question is asking find out the total work and the change in internal energy and the heat. So first of all, let's see how we can easily calculate this one. To find this one easily, to find the work easily, we just have to take, whenever we have cyclic process, we just have to take the area inside of it, right? So here if I calculate this area of this rectangle, that's going to give us the total work. So we know that the area of rectangle is going to be width times the length. So width times the length, length, and then we know, oh, here it's better to say height, right? So let's consider height as a width. And if you look at this one, the difference is going to be 1 atm because 2 minus 1, that's going to be 1 atm. 1 atm times length is going to be 60 minus 20 liter. That's going to give us 40 liter, right? 40 liter. And then to convert this one into joule, I have to multiply this one by 101.3 joules per mole atm liter. atm liter. So from this one, atm and liter cancels each other, and then we get the final answer in terms of in terms of joules. So here, if you calculate this one, that's going to give you 4052 joules, and that's the total work done by the gas, right? Done by the gas. Because if the answer is positive, we know that's done by the gas. So let's look at let's see how we can calculate this in different way without using this area kind of thing, right? So what we can do is, to find the total work, we can do another thing. The total work is going to be addition of each process. So if you see, this is one process, 1 to 2 one process, 2 to 3 another process, 3 to 4 another process, and 4 to 1 the complete process. So if you add them together, like W1 to 2 plus W2 to 3 plus W3 to 4 plus W4 to 1. If you do the calculation, you have to get the same answer. So let's look at what happens in the W1 to 2. If you look at this one, there's a vertical line, and you know the volume is going to be constant because volume at 1 and 2 is going to be same, right? So whenever we have this is called isochoric process or isovolumetric process. So it's called by two names. So in this, whenever we have that kind of situation, the work is always zero. So for this vertical line and PV diagram, whenever you see vertical line, you can just say zero. So here, this is 0, 1 to 2 is 0, and 3 to 4 is 0. So we can say this is, instead of, let's put 0 for this one, and 3 to 4 also a vertical line, right? That's volume, constant volume. So that's also going to be 0. If you want to know what's the reason, there are two ways we can explain this one. If you do the equation that W is equal to P delta V, we know that volume is going to be same, right? Initial and final volume is going to be same, and delta V is going to be 0 because V2 minus V1 is the delta V, right? So if delta V is 0, the whole thing is going to be 0. So that's one way to explain. Another way, if you take the PV diagram, we know that to calculate the work, you have to calculate the area below the whatever the line you draw. So for a vertical line, there's no area below that one, right? So in that way, you can say it's 0. So there are both ways to explain this one, two ways to explain this one, and then let's go to the W2 to 3. If you look at 2 to 3, the pressure is constant. So this is called isobaric process. If you look at that one, 2 to 3, pressure is constant. Here we can use W is equal to P delta V, right? Pressure is constant. So pressure is going to be 2 atm. Let's calculate maybe separately, or let's calculate here. So instead of write this, let's write this one later. So this is going to be, I'm doing 2 to 3. That's isobaric process, 2 atm multiplied by delta V. Delta V is going to be final minus initial. So 60 minus 20. So this is going to be 60 minus 20 liter. To convert this one into joule, I have to multiply this one by 101.3 joule per atm liter, right? And let's look at the other one, 3 to 4. Again, vertical line, volume is constant, therefore work is 0. And then 4 to 1, again we have isobaric process, we can use P delta V. So P at 4 to 1, it's 1 atm, so this is going to be 1 atm, and delta V is going to be final minus initial. So here it's going from 4 to 1, right? If it's going from 4 to 1, it's going to be 20 minus 60, because 20 is the final volume, right? 20 minus 60, 20 minus 60 liter. This answer is going to be negative, because whenever we in PV diagram, if we have the work in this direction, that's always negative. If this is negative, and if we have work in this direction, that's always positive. So in this way, you know you have to get a negative answer right here. And here again we have atm liter, we have to convert this one into joule, so we multiply this one by 101.3 joule per liter atm, right? Let's do the calculation. So here we're going to get 0, this is going to be, if you calculate this one, that's going to give you so let's do the atm liter part first. So this is going to be 40 times 2, 80 atm liter. 80 atm liter times 101.3 joules per atm liter plus 0 plus here you get 1 times 20, 40. So it's going to be 40 atm liter, and it's negative right here because this is negative 40, so that's going to be negative 40 atm liter. 40 atm liter multiplied by 101.3 joule per liter atm, right? Now we can go ahead and simplify this one right here. So here 80 atm liter, 40 atm liter, both are multiplied by the same value. So we can directly subtract this one. So this is going to be 40 atm liter times 101.3 joule per liter atm. And if you notice this one, 40 times 100, 4000, right? 40 times 1.3 is going to be 52. 40 times 1.3, 40 times 1 is 40. 40 times 0.2 is going to be 12. So that's going to be 52. So if you look at this one, same answer. 40,052 joule. And that's how we do this kind of problem. And they are also asking for the total Q and delta U. And delta U is easy. Whenever we have cyclic process, delta U is always 0. Right? Delta U is equal to 0. If delta U is equal to 0, we know we can apply the first law of thermodynamics to find the Q. First law of thermodynamics says delta U is equal to Q minus W. If delta U is equal to 0, Q minus 0 is equal to Q minus W, then from this one we know Q is equal to W. Right? We calculated W already, that's 4052 joule. Therefore Q also 4052 joule. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.